Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Bionic. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting webinar, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our webinar or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you do have any questions for Matt, we want you to send those in using the Q&A tab, which is found on the right side of your screen. That's also where you'll find the chat tab, where we want you to chat with your fellow audience members, chat with us, let us know your thoughts throughout today's webinar. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around till the very end. Our topic today is why cloud-native applications and APIs are at risk. And I'm joined by Matt Rose, Chief Architect at Bionic. Matt, thank you so much for joining me. I'm going to let you take it from here.
Oh, thank you very much, Cody, and thank you for everybody joining today. Let's just bring up the presentation. All right. Well, thank you, everybody, for joining today. I'm Matt Rose, Chief Architect at Bionic, and today, as conversation is going to be around why cloud-native applications and APIs are at risk. We're going to kind of go through a little bit of a story to kind of discuss what people are doing in terms of cloud risk for their applications and how different approaches may be new to you or different to you in terms of solving this problem. Just by a little background, I've been in the application security space for many years and really focusing on SAST or scanning source code. But I really feel that the explosion of cloud and the explosion of cloud native applications has created a new paradigm and a new paradigm of risk that we really need to address. So we're going to get in, and I'm going to try and keep this a little bit light. I have a lot of comedy in the slides, so I want people to enjoy the presentation. I don't want this to be a boring presentation, so we're going to jump in and get going. So, as you know, cloud infrastructure is a big deal. According to TechCrunch, the cloud infrastructure market soared to $178 billion in 2021, growing $49 billion in 1 year. We use Ron Burgundy as an example here that, I don't know if you know this, but cloud's kind of a big thing. Just like Ron Burgundy was a big thing, cloud is a big thing. There is initiatives around cloud, initiatives around securing the cloud, but what about the applications that live and deploy to that cloud environment? How are those going to be secured with the associated APIs? So we're going to talk about the things associated with what cloud or cloud security posture management solutions do well and where they kind of fall down, where you may have a cloud secure cloud infrastructure, but your applications are not secure. And we're going to talk about a lot of details. And please, if you have questions, please drop them in the Q&A. I will address them at the end of the presentation, because I really think that, the only bad question is a question that's not answered. And hopefully we can get to those and get some interaction with the Q&A at the end. So you've probably heard of these guys if you're talking about cloud or securing your cloud. Cloud security posture management solutions, Lacework, Prisma Cloud, Wiz are doing a great job of securing the cloud infrastructure, making sure it is configured correctly, that there's no risk, that there's user privileges are all in line. But secure cloud infrastructure does not mean secure cloud applications or cloud native applications or the associated APIs with them. So just by having a cloud security posture management solution, you're not totally secure. You're only 50% of the equation secure, and that's on the infrastructure side, not on the application side. So CSPM core functionalities or cloud security posture management core functionalities. We have Dilbert here. The cartoon I think is pretty appropriate because you bring in a consultant, they say cloud, 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 and people think it's the most amazing thing. But they truly don't understand that just having the secure cloud doesn't mean you're completely secure. It's not a joke. Cloud does a lot of amazing things, but it doesn't do everything. And cloud security posture management solutions don't do everything in terms of the risk of your cloud native applications and associated APIs. So little humor, we'll get going in. So CSPM core functionality number 1 is detect and auto remediate cloud infrastructure misconfigurations. The cloud providers, doesn't matter which one it is, all release the standard of how things are supposed to be configured, what the steps are to have a secure infrastructure environment for that cloud. CSPM is very good at telling you if it's misconfigured based on the standards. It tells you if that cloud is configured correctly, if all the permissions are set up, and so on and so forth. So one does not simply deploy a cloud infrastructure. You need to deploy a cloud infrastructure secure. But again, there's no mention of the application here. We're still missing the configuration and the insights of risk associated with that application that lives in your cloud. Core functionality number 2. A lot of times when I work for Bionic, as you know, application security posture management, people immediately see a visual map of something and they think it's a CSPM solution. CSPM does a great job of providing an infrastructure view of that cloud environment, all the connections, all the services of the cloud infrastructure. But it doesn't give you a granular detail or insights into the application itself. It can kind of see what's happening in the application from the outside in, but it's not full contextual view. A visual map of cloud services is very important. It tells you, exactly what your cloud infrastructure looks like, but it's, again, not telling you the whole story. You're still missing the risk associated with the apps deployed to that cloud infrastructure. CSPM core functionality 2 is cloud infrastructure drift. So in this, again, trying to use a little bit of humor, you think you've deployed this beautiful cloud infrastructure and it drifts away from the standards. So your cloud isn't really an accurate representation of what you think is in there. It's changing. And that's why cloud security posture management really looks at that drift of infrastructure for cloud services. And I say cloud, I put the air quotes on that to make sure that we're talking about the infrastructure, not the application. So you think your cloud infrastructure is perfect. It's the Mona Lisa, but it's actually a kid's representation of the Mona Lisa. It's gone away from what you intended. That's why continuous monitoring of the infrastructure is important. But again, we're going to get into details of where there's gaps associated with the applications that live in your cloud environment. CSPM core functionality number 4, an SBOM of all cloud services, information about all the cloud services and everything that's being used in there. I use GRU for this. You always ask a supplier to provide vulnerability info associated with your cloud infrastructure. They can't provide it. You ask them for an SBOM, and then it's kind of you're stuck in the mud and playing this continuous game of asking for things that you don't even have. So an SBOM of cloud services is important. All the cloud services, how the connections, everything in there. But again, you don't know what's in the application. What is the application architecture really being put together in terms of the functionality, the services at the app level, the frameworks, the vulnerabilities. We'll get into that in a little bit. So continuous monitoring of cloud infrastructure. So monitoring the infrastructure, seeing if patches are done, seeing resolved issues. So continuous monitoring of cloud services, not application services. If you see there's a trend going on here, just by buying a cloud security posture management and securing the cloud infrastructure, you're missing the boat in terms of the risk and the insights into your application architecture risk and the associated APIs. So having a very fancy dashboard like we have a screenshot here is important, but you're, again, only getting half the equation associated with the risk of the infrastructure and the application itself. One of the other big things is it's all about data. Everything's about data, identify data storage risk, and there's a bunch of different ways. Human errors, publicly accessible S3 buckets, improper ACLs, and bucket policies. All these things are very important, and cloud is very good about identifying, or CSPM is very good at identifying these type of things. They do that as part of the process, and one of the core competencies that a CSPM has is to tell you about misconfigured or unencrypted S3 buckets or storage services within the application. Detect policy violations. You always have to have policies when you're looking at things you need to look for, things that are automated. And all these things that you're finding with the CSPM are related to the cloud itself, not to the application. So you can kind of get an idea of what's happening in the infrastructure, but you don't know what is the risk, what are the CVEs, or what are the vulnerable data flows at the app level, or what APIs are being called, and are they actually touching services with CVEs, so on and so forth. So the policies from a CSPM solution are really around just that infrastructure and nothing to do with the application itself. Cloud provisioning and automation that can automatically update, Terraform or different ways to actually provision the cloud with IAC. It's not magic. It is a technology. A lot of people think it's magic, but cloud provisioning through CSPM, and not all CSPMs do this, but it's very easy to spin up and spin down environments based on need. So again, this is a CSPM core functionality. It's not an application-specific functionality. And one of the last ones, and we had to bring Oprah in here too, for monitor account and role permissions. I mean, you get a permission and you get a permission. Everybody gets permissions. One of the biggest problems in cloud environments or cloud infrastructure environments is overprivileged accounts. If they're doing something in the environment, you want to give them least level privilege of the application or of that capability. So looking for overprivileged IAM roles or things like that is very important. So you're basically eliminating some risk. If somebody doesn't need full admin or full functionality within an environment, pull it back from them. And that's an ongoing process with basically the fluid nature of that cloud environment as a whole. So that was pretty cool. But Houston, we have a problem. And I'm going to talk about this just conversationally here for a minute. You know, the way CSPM sees solutions is through a pair of binoculars. It kind of sees the application, it knows it's deployed into that environment, but it really has no context or insights about the architecture of that application, the risks in that application. So when you talk about securing your applications that are deployed to the cloud, you need to have a full visibility kind of approach to the application risk, because you're going and spending all this money and resources and time to basically make sure the infrastructure is secure. But what if that application is architecturally flawed? What if it has unencrypted communications to a third-party API? What if there is a CVE that's touching PII data? How do you address that? Or how do you address risk in your application that are specific to your architecture? And you can, spend all your money on AST scanning solutions for open source packages or source code, but you truly don't know the context of the risk in your application and the insights about risk scoring, sensitive data, and all the things you're kind of concerned about within your application itself. So when you think about CSPM looking at an app, it's like looking across a harbor through a set of binoculars. So gaps in CSPM functionality that application security posture management solves: number one, and all application data flows and services. So we saw a map previously. That was the cloud infrastructure. It was all this cloud services and how they communicated, how they were all configured correctly or incorrectly for that matter. But within this map for the application, you can see all application services, web applications, databases, third parties, message brokers, all the different aspects that make up this application. You're not going to get this through a CSPM solution. You're going to have this gap or this, misunderstanding of the risk in the application itself. This shows you all upstream and downstream data flows. It shows you all services, whether they're configured correctly, whether critical services access PII data and then touch a third party. We're going to dig in a little bit deeper. But a lot of times when people see a map, they automatically think CSPM and cloud services. No. ASPM provides you that same lens or that same context, that same insight into the complete architecture of your application. This is kind of a game-changing technology, in my opinion. I've been in the industry 20 years, and I've always said, everybody looks at an application for risk, for structured type risk or vulnerabilities that are known, but they truly don't know what their application looks like. They don't have insight into the application itself about all the upstream and downstream data flows, all the connections, all the services. What ASPM goes above and beyond CSPM is finding all these services and showing how they all work together. We talked about cloud architecture drift. That's the services or the architecture or the infrastructure drift of cloud services. Application service drift, I think, is almost more dangerous because it is introducing a new connection or a new service that may be doing something you don't anticipate or you don't see. So as part of ASPM, as part of the process of mapping your application through artifact collection and a reverse engineering process, we can identify a new service that potentially is touching sensitive data. So in this example here, this supply track service is a new data source connection to Tracker DB. You may not know this is happening. You may have misunderstood the architecture, or somebody had maybe pushed something to code, pushed something to production, or even staging that was outside the architecture. And you want to make sure that you know the complete architecture as it's approved, and not if it drifts away, kind of like that Mona Lisa picture. But I, figured I'd use a real-world example here of something changing that produces a new data flow, a new risk, and maybe potentially accesses sensitive data. So application service drift is a huge problem because you're releasing so quickly in your application ecosystem. That CI/CD process is running tens, maybe hundreds of times a day to release new code and microservices and dependencies to a production environment. How do you keep up with that, and how do you make sure that you don't drift away from the approved architecture or the approved data flows for sensitive data in your application? So thinking about that, how do you do that today? And maybe drop, if people have questions about this, please drop them in the Q&A session to kind of talk about, how you're identifying application service drift today. How are you going about, making sure that new services are not talking to sensitive data or misconfigured, secrets management, so on and so forth. You want to make sure that you know what is happening in your application and you have the insights into what potential risk could kind of rear its ugly head if this is introduced to the application. So one of the other ones I mentioned, this kind of highlighted in this, is looking for misconfigured secrets in an application. CSPM is not going into the application level. They can't see the code itself and understand that there is a hard-coded secret or a misconfigured secret in the application itself. ASPM really provides you that because it's reverse engineering the code artifacts themselves, the WAR files, jar files, EAR files, configuration files, and the associated environment variables. So it basically can understand everything that's happening and see a hard-coded secret in an application. Yes, CSPM looks for misconfigured communication within that cloud role or that cloud service user account, but it has no idea about the accounts that are used within the application itself. And again, with constant updating through a very aggressive CI/CD process, you want to make sure that the secrets in code are addressed very, very early. And if something changes and there's all of a sudden a violation in terms of a secret in the code or the application, that it's addressed very quickly. And as you can see on the right-hand side, just because this application has a secret in code, it's immediately ranked up from a critical violation or a risk score of 100, because that is a major critical issue that you need to address before anything else, in my opinion. Multi-level application risks. Again, CSPM is not looking, it can't see this level of detail or the insights into this specific area of the application. When I say multi-level, things that happen in concert or are a step process. So in this example, this service, Customer AI Analytics, has a CVE, a critical CVE, or a moderate CVE within the application. Okay, that's interesting. I already knew that. But did you know that it also talks to a database with PII data, which is represented here by Customer Portal, and it also talks to a third party, Tableau.com. These are the type of things that are hard to find for any solution these days, not just CSPM or the AST scanning. They just don't have this insight and context into the application data flows. And to see that this critical, the CVE talks to, accesses PII data in addition to a third party. This is something that I would be concerned about and raise up in terms of the risk, because it does have kind of the trifecta of risk with PII data and third-party communication. So these are the hard things to find, the multi-level risk applications. And the only way that ASPM can do that is because we're reverse engineering the code itself and basically providing you with this architectural insight into all aspects, not just one service or one database or one data flow, but all data flows, all services, all connections within that application architecture and ecosystem. CSPM functionality that ASPM solves, number 5, identifying and prioritizing zero-day vulnerabilities. You're probably saying, Matt, everybody talks about 0 days, Log4j or Spring Shell or things like that. The issue is finding these vulnerabilities once they're released, once all the information is provided, is easy. Yeah, it's not, oh, let's take that back. It's not that easy, but it's easy just to say, do I have it or not? But the thing is, you maybe have 10,000 issues or 5,000 issues or even 1,000 issues that say these are the packages or these are the areas of the application that need to be updated. The real kind of problem in the equation is prioritizing. Okay, if I have 1,000 instances of a 0-day that I need to fix, which ones are the ones I need to fix first? Which ones are the ones I need to fix second? And which ones, I don't really need to worry about those because of X, Y, Z. What ASPM really helps you do is prioritize based on a set of criteria. Do I have this issue? Yes. Where does it live in my application? Yes. And how does it basically access other aspects of my application? Does it touch PII data? Does it touch third-party connections via an API? So not just finding the zero-day vulnerability, but actually prioritizing which ones to fix first, make you more secure quicker, rather than just saying blanketly fix everything. Because we all know an application, all applications have risks. There's no such thing as a completely secure application. There's always risk. It's about prioritizing which risk is most important to fix with the budgets, resources, and time you have available. Not all vulnerabilities are treated equal, and ASPM does a great job of prioritizing risk, like 0 days or many other types of violations. Continuous updated application-specific dynamic bill of materials. Man, that's a mouthful. What does that mean? Well, a lot of times people have an SBOM or a software bill of materials that's in another system, a CMDB, or it's a questionnaires, and it's not up to date. Because again, through your CI/CD processes, you're releasing tens or hundreds of times a day. That SBOM that you have for your application, maybe it's just focused in the cloud environment or your open source packages. It's not up to date based on all the code pushes. What ASPM really provides is a continuous updated dynamic bill of materials of the applications that you're scanning, you're reverse engineering and mapping with ASPM. So if you see on the left-hand side, the summary, all of this information associated with this bill of materials from data sources, topics and queries, APIs and interfaces, dependencies, frameworks, libraries is continuously updated. So that kind of going back to that GRU slide in the beginning in the cloud section, that SBOM that you provided, that dynamic SBOM you provided by an ASPM solution is complete and accurate. It's code accurate. It's not an exercise in people dragging a bunch of different systems together, the questionnaires, the CMDB, the tribal knowledge of a bunch of people of what's in the application. The dynamic bill of materials provided by ASPM is providing a up-to-date bill of materials, not a dated one. It's based on the code. Number 7, security risk and misconfigured issues unique to your application. Again, I mentioned that I've been in application security 20 plus years, and I still find it very, very interesting that we're all looking for the same vulnerabilities we've been looking for forever, the SQL injections, the cross-site scriptings, the OWASP top 10 vulnerabilities. Yeah, those are important, but everybody's looking for those. A lot of times, the architecture of your application is rolled out in a way that has unique vulnerabilities that are only specific to your application. And understanding all the upstream and downstream API calls, all the data flows in your application, all the services and all the interaction of those services is vital, because a lot of times a vulnerability is only unique to your application, or one part of the risk is unique to your application. So in this example, this unique unencrypted communication to this database is only being found by ASPM based on us understanding all of the architectural services of the application. So thinking about data flow and thinking about unique things, is this application configured in a way that has risk, but it's a unique risk that nobody knows about? Because if you don't know what to look for, you're never going to find it. And ASPM is great at providing you with that full context, that full understanding of the application and all the risks. Some known risks, such as CVEs or misconfigured secrets, but some things that are unique to your application. So if you don't know what to look for, you're never going to find it. Automating continuous application threat modeling. This is kind of a side case, but something I'm very passionate about. Threat modeling has been around forever, and it was a very manual, drawn-out process. You had to go through a whiteboard session or Visio diagrams or lucid charts, and then you'd have some sort of methodology that would draw a representation of an application. And that was based on kind of tribal knowledge, crowdsourcing of information. What are the services? How do they connect? What is the risk associated with those services and how they connect? So what ASPM really provides you is a code accurate map of the application, very similar to your threat modeling practices of, drawing things on a whiteboard and then saying who, what, when, where, why, and do I care about that? And really smart people using hypothetical questions. What if we change this? Or what if we communicate it this way? And the risk associated with that. What ASPM as a side kind of capability is to automate threat modeling in a way that is continuous. And I've used this term. It's like what ASPM brings to the threat modeling world is not your grandfather's threat modeling. We're not talking about Stride or Pasta or Trike or the methodology. We're talking about a brand new way to threat model based on the code itself, and not a subjective conversation with a bunch of people in the room with pizzas and interrogation type of situation where you're talking about all the potential risk or hypothetical risk an application would face based on the architecture itself. This is really a game changer in terms of making threat modeling much more automated than it has ever been before. We saw the map. We saw the screen with the policies and information associated with the CSPM. You can make sure there's not changes or there's misconfigurations, and I don't want to see it configured this way. ASPM does that at the app level, not at the infrastructure level. So policies are specific to your application. Things like unencrypted communication, unauthenticated APIs, secrets in code, PCI tagging classifications. There's many different things you can do in creating a policy. And then the way it works is you create a policy that has a group of similar rules that are all based off of queries. These queries are basically the investigation point of the application. It's very easy to understand things that are specific to risk, and this is the default policy. But there's other types of policies you can create with ASPM that really help you understand the risk in your cloud native applications and their associated APIs, from drift to cloud native to compliance concerns like NIST 800-53 or GDPR. All of this is based on that reverse engineered code, and it's complete insight into the risk in the application. And this can be automated to send emails or Slack messages or Jira tickets to you to basically get this in front of people as quickly as possible. Again, just focusing on the cloud and that huge investment in your cloud infrastructure security with CSPM solutions, you're never going to have this, and you're not going to understand this risk. So really, it's a black hole, or it's something you just don't know about if you don't have ASPM solution and all the insights it provides to end users as a whole. One of the things too that we're thinking about too is dependency mapping. So understanding all the dependencies of an application. There's actually a real world example that I saw where somebody moved an application from one cloud provider to another, thought they had all the dependencies, and they missed something, and it caused the system to go down for many, many hours. We are looking at the code itself, so we understand all the dependencies of an application. So understanding the dependencies allows that application to work correctly. This is, again, a side effect, not a side effect, but a side capability of that dynamic bill of materials. When the code is run through ASPM as part of a new release, it really provides you with an updated list of dependencies. So if you have to do something or something happens, you understand all the dependencies of that application, not just cross your fingers and hope that I know all the dependencies, or I missed something because somebody didn't understand a certain component of the application. Again, everything that ASPM provides you is code accurate, because it's looking at and basically investigating the artifacts themselves. Again, WAR files, jar files, EAR files, DLLs, all the associated code and the environment variables and configuration files to provide you with the information. Because the code that's being deployed to your application is exactly what Bionic looks at, so it's accurate based on the code. So there's a significant gap in cloud native app visibility. Again, the guy with the binoculars looking at it, you can kind of see it. You're looking at it from a distance. You're trying to see what it is. You're trying to understand what it's doing. You need to mind that gap, because if you're just looking at the cloud infrastructure, you're not getting pure security insights of the risk of your application architecture, how it changes, what new risk is potentially being introduced by a code change. How do you actually prioritize and find zero-day and new vulnerabilities? How do you understand multi-level type threats in your application without understanding full context? In addition to risk scoring of application based on many different criteria and tagging of different types of data in the application, you have complete context when you're using ASPM, not just a CSPM solution and legacy AST type scanning solutions. CSPM and ASPM, I think, are the best approach to securing your cloud native applications, because it gives you full insight and context. And just a closing couple statements here. CSPM is great for your cloud infrastructure, but it's only 50% of the problem. Secure the infrastructure, don't secure the app, you got a problem. Something I like to say is cloud, we saw this before, secure cloud infrastructure does not equal secure cloud applications. A lot of that insight and a lot of that information I said on the ASPM side of the house is totally kind of different or unknown to the CSPM solutions or the cloud architects. Understanding the app is just as important as understanding the application of the cloud infrastructure. Some interesting areas to do a little bit more research. I actually host some Glassboard sessions where I talk about interesting topics, everything from, ASPM to API to AST solutions, the history of AppSec. It's Bionic Uncensored. Check it out. It's a great platform that I like to use. And a lot of times I'll do webinars. I didn't do it today, but it really is interactive and people seem to like the format. And if you want to, listen to my podcast, I have I think 15 or 16 episodes released of different AppSec professionals talking about different, trends in the industry, things they need to be concerned about, and just general conversation to help educate the application security world as a whole. So with that, it's question time. And again, because I was in full screen, I couldn't see the questions. So Cody.
All right, Matt, let's take them from the top. So the first question we received reads, can you define the definition of CSPM from a Bionic perspective?
Absolutely. So you think about CSPM, Cloud Security Posture Management. The first letter is C. So the architecture that you're looking at is the cloud infrastructure. Application Security Posture Management in the Bionic world, in our term, basically represents the services of the application. Again, the web applications, databases, message brokers, third parties, upstream and downstream. So it's all application specific, where Cloud Security Posture Management is all about the cloud services, cloud drift, misconfigurations in the cloud, misconfigurations of your S3 buckets or overprivileged roles within that environment. So they complement it. They're the same concept, but the data that ASPM brings to the table is application specific, and Cloud Security Posture Management is cloud specific. Again, you need infrastructure and application architecture for something to work correctly.
Great. So, Matt, I think that actually ties into our next question fairly well. So, is ASPM a new industry buzzword, and who coined it?
It is. It's something that's actually starting to gain a lot of traction in the industry. You're thinking about the type of data that ASPM provides. So application security posture management, a lot of people are talking about it as different types of definitions. A lot of organizations out there are saying it's a collection of many different sources, from SaaS vendors to software composition, and putting that together and creating the posture of your application. Is your application's posture secure? At Bionic, we're taking a different approach. We're basically using reverse engineering and a collection of application artifacts to provide a code-accurate map and all the insights to it, which are then queryable policies, rules. It's really, I don't know if you can look out there, I say it's about a 6-month to 1-year-old concept associated with application security posture management. Some people define it differently, but just the buzz around the technology is real. I have real data points because I was at RSA a couple weeks ago, and when people saw ASPM, they were basically saying, I've been looking for something like this forever. I need to understand the architecture and the basically connectivity of all my services of my application, and I've never seen anything like this. So it is a new technology. It's starting to gain a lot of traction. You do some Googling around, you'll see a lot. You learn a lot too if you go to the Bionic Uncensored, the link that I sent up before. I can put it in the chat before we go out. But I think it's something that is needed by the industry because change is happening so quickly. The only way you can actually understand the true insights and risk of your application is with ASPM.
Great. So this next question reads, can you advise any frameworks or industry tools used in Bionic, quote, application threat modeling?
Can I say that one more time? I didn't get
so can you advise any frameworks or industry tools used in Bionic application threat modeling? So
again, Bionic's approach to threat modeling is much different than anything else. That's not based on the methodologies or the old way of doing a whiteboard session and then a lucid chart or a Visio diagram and then threat modeling the questions. It's not based on those methodologies. It's basically providing you with a complete architecture map that then the queries are that threat modeler's activities, where it asks questions of the application in terms of risk and threat, like where does data go? Where is data coming from? What are the potential misconfigurations around that data flow of the application? There are threat modeling solutions out there, but they're based on kind of the older methodology of just putting together a visual document that could be accurate, it could be inaccurate. It's just a totally new approach. And I've talked to a lot of threat modeling experts, and they say, this is what we need. This is true automation of threat modeling, because it not only automates the threat modeling aspect, but the design of the map or the architecture as well.
Great. So this next question is kind of to the point, but is there no foolproof way to say we have ourselves covered?
I always like to say there's no such thing as a secure application. You always have to be proactive and find things as quickly as possible. And without full context, you're never going to understand it. So if you're just looking, I like to say application security as a whole is really like a pizza. And everybody's looking at a slice of the pizza. You're looking at the API slice or the source code slice or the running application slice or the API slice or all the different aspects of an application or a pizza. If you're just looking at one lens, you're only going to find those two vulnerabilities. Having insights to full context, how do the APIs and the source code and the third-party connections and misconfigured secrets all produce unique risk? So thinking about that is we're going down the path of looking at everything in a silo instead of as a complete ecosystem. What ASPM brings to the table is complete contextual risk of your application architecture and everything in it.
Awesome. Thank you so much for that, Matt. This next question reads, in your opinion, how important is data classification in ASPM? And
it's very important. Okay. Yeah, it's very important, because understanding what sensitive data is in the application, what services are touching it, what risks are associated with those services. So if you have a web app service that has a critical CVE for remote code execution, and that has a direct connection to a database or a data store with sensitive data, it's very important to understand that. Based on the way that we architect, reverse engineer and architect the application, we can ASPM can see all the way into the database, into column, table and column name. So we understand and can automatically tag PII data in the application. You also have the ability to manually tag things if you wanted to go above and beyond the automation of tagging information in the application. So if you see a table in a database being called from a service that is called users, and then the columns are DOB, SSN, FNAME, LNAME, that's PII data. And then you see that that's one step away from a third-party misconfigured API. That's a risk that you need to address immediately, in my opinion.
So right now I'm seeing we have one final question. So I'll give our audience a reminder that this would be the best possible time for you to send in any questions that you might have. So this one reads, this value proposition seems interesting, but how do you respond to someone who says, okay, but doesn't Azure already do that?
Well, again, you're looking at Azure at the cloud infrastructure level. You're not looking at it at the application. The stupid analogy I like to use is like Azure or any cloud provider is basically the shoebox. The applications are the shoes that live in the shoebox. If you're just securing or making sure that shoebox looks really pretty, you're totally ignoring the shoes, which is really what you want. The only reason why you have a secure and well thought out and built out cloud architecture or infrastructure is to deploy apps to it, is to use it for something. And if you're basically just worried about securing the infrastructure itself, the app has risks that are totally different and totally disconnected from that architecture. So thinking about the risks, critical CVEs, data flows, misconfigured secrets, third parties, access to third party without proper authentication. These are all app-specific things that will never be found by any of the cloud standards or CSPM solutions.
Well, wonderful. Thank you so much, Matt. I'm going to take this opportunity to remind everyone that this session was recorded. So following this webinar, you should be receiving an email with a link to access the recording on demand. You can also find the webinar living on the DevOps website, on the Security Boulevard website at securityboulevard.com/webinars, and be sure to look in the on-demand section. We also do have 4 $25 Amazon gift cards to give away. So our first winner is Francesca D. Our second winner is Victor A. Our third winner is Amir L. And our fourth and final winner is Lynn A. So congratulations to the 4 of you. Please keep an eye on your inbox to claim that gift card. But if you don't see that email, check your spam folder. So Matt, I'm not seeing any. Oh, I'm seeing one final question. Somebody got one in time. So do you support ANU workloads? I'll go ahead and just.
I'm not sure what the context and infrastructure as a service, software as a service. I mean, yeah, we're cloud agnostic, and we basically can work with any cloud environment. We're not specific to any cloud environment. It's more about the application artifacts itself. So, IaaS, PaaS, and SaaS environments, we're cloud agnostic. We can work with any cloud provider because, again, we're just looking at the artifacts of the application that are being deployed, not the specific cloud environment. So we work with all cloud environments or even on-premise applications for that matter.
Awesome. Thank you so much, Matt. So that does exhaust our questions. So is there anything you'd like to leave our audience with? Any parting words before we close out this webinar?
No, appreciate everybody taking time out of their busy schedule. Again, I'm very passionate about application security posture management and the insights it provides. I haven't seen a technology like this in years that really kind of flips the industry on its head to truly understand things that have never been seen before. Again, if you want to learn more, check out bionic.com. Bionic.ai. In the resources section is my podcast and the Bionic Uncensored. The Uncensored are a great learning solution for many different topics around how ASPM really helps solve new problems of modern cloud native development processes.
Well, Matt, thank you so much for joining us today. I really appreciate you taking the time to sit down and explain all this to us. I would like to thank Bionic for sponsoring today's webinar. And of course, I would like to thank our audience for joining us today. We really appreciate you spending your time with us. We ask for one extra moment of your time to fill out a brief post-webinar survey that should pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong Learning workshop or webinar. Everyone have a great rest of your day. And Matt, thank you once again.
Thank you, Cody.